This
in the IT
conference will
industry.
now be recorded.
Yeah, so I'm having 12 years of around 12 years of experience in the IT industry. So
Mhm.
basically, I am into in the database things only. I am a database developer, Oracle PL SQL, and
Okay.
Unix, all these things.
Mhm.
Um, Current means I have total experience in the service-based company only, not the product base.
Okay. So you started working as a PL SQL developer from the beginning,
Yeah,
and
database.
current,
Yeah.
yeah.
Yes, yes.
Okay. So
Earlier, I
it's
was into
Oracle.
production. Yeah. I was into the production support of Oracle and SQL Server. Now,
Mhm.
in totally be in the development side only now.
Okay. Okay. Yeah. Just a quick fair question for Jubair. What's the expectation you are looking at?
So my aim is to just I'm just moving from the technology and want into the data engineering side only. So as you said that the data engineers it's a booming technology right now.
Yeah.
So I want to be part of that and I want to learn all this time. So all these things.
Okay. So I can preferably say you are looking for a switch kind of thing or job change kind of thing.
Switch kind of thing in terms of the technology, not in terms of the company switch.
Okay.
Yeah,
Yeah. So you want to move from PL SQL background to the you can say data engineering part.
correct.
Okay, thank you. Thank you, Jup. So what will maybe have a after registration we might have a discussion how we can plan. So how we'll set up your thing so that you can show these many years I worked in PL SQL or database and these many things I worked as a data engineering. So we have to structure the curriculum. Actually, we are covering the curriculum everything in a fly, but for this means a high experience background, we have to cope up the things. We have to make the resume such a way that it will be looks good when you are getting interviewed.
Okay.
Yeah. So will take care of these things. Subha, can you forward to you?
Hi, myself Subhasri. I am having more than 8 years of experience in IT industry, and I'm currently working as a manual tester. And I have knowledge on SQL and Unix. And I want to learn big data, Hadoop, and Spark to upskill myself. And if opportunity comes, I want to also switch both technology and company.
Okay, thank you. So you've been working as a manual ETL tester or simply
Manual tester.
okay, okay,
Functional
yeah,
tester.
functional tester. Yeah, thank you, so. Irshad, anything from your end?
Yeah, I'm working as a rate mod in the sense it's like a ETL developer extracting data and processing data. So in that in current domain I'm working for nearly 4 years of experience I do have. Initial experience was in networking side, so kind of a support. So initial part comes under data side only, so planning for big data.
Okay, okay. Okay. Thank you guys. I got heard up something that you guys are already in working environment and you want to maybe upskill your technology, you can say, and if get chanced, you will go to the big data environment, or we can say that data engineering sector. Okay. So thank you for your brief introduction. Let's started with our agenda of these things and how we'll plan of all of the things. Okay. Let me share my screen. Okay. So first I'll walk through of the syllabus, what we are covering here and what we are going to maybe cover in the upcoming, we can say 60 to 70 hours, maybe three months of timing, and what's our agenda will cover and what you will get after the all these months of learning. So this course is in working in collaboration with Digital IT Hub, and it's a good organization to get enrolled with. Digital IT Hub is basically leading with all the data related stuffs like ETL, data engineering, and all these things. So for any related data engineering courses or ETL or data related course, you can go to Digital idea. The coordination team will assist you. Okay, moving forward to the next topic, what will be the course agenda? So I think after the session, coordination team will help you guys to forward this PPT, whatever I'm showing you throughout the session, so that you can go and all these things. So coming to the requisites or prerequisites or educational qualification, we don't want any prerequisites. It's if you have basic knowledge in Unix, SQL, that will be well and fine. And another things, coming to the programming, yeah, many we can say learners have a doubt that whether I need programming language enough or not. But no, we'll cover the programming language Python here, because we are dealing with the PySpark programming. Whatever the knowledge required for the Python to write down the PySpark code, I'll take it from the scratch. If you have knowledge on the programming language, it's well and fine. So we can it's an additional benefit for you. Okay, so what are the things we are supporting here? Will guide you for the end-to-end course completion from so what are the technology you will get: big data, Spark, Hive, Hadoop, you can say Databricks. It's a kind of I think any one of you guys heard about Databricks? Hello
Yeah,
guys, are you?
heard about, yeah, I heard about Databricks, but exactly don't know how it works. I
Okay.
mean,
Okay. So Databricks. Okay, I'll cover what is Databricks, and if needed, I will go away. So as a cloud functionality, so in the day-to-day market, let's say for example, you guys have knowledge on the SQL. So whenever you're writing the SQL code, you are writing in SQL developer or Oracle developer, or previously it was stored. Correct? Jubair, Irsad, and Suba. I think you guys have knowledge on SQL. So I can expect that whenever you are writing your code or select start from something, you are connecting through SQL developer, or kind of you can say my SQL, Microsoft SQL Data Studio, or someone connected with Toad. Similarly, whenever you are writing a Spark code, or you can say your um, your big data code, so it's a cloud experience where you can write your code and all these things. It's not particularly IDE. Let's say for Java, it's a IntelliJ, or you can say Eclipse are there. It's not a particular IDE, it's a framework. So cloud framework like AWS, GCP, Google Cloud, or Azure. So it's a Azure Databricks, part of Azure. So where you can write your code and all these things stuffs, and you can manage your cluster. So it's a package which is responsible for, let's say previously it was Cloudera. So Cloudera and Huttonworks. Have you guys heard about the two terms, Cloudera and Huttonworks? These are managed or organization which organized your big data Hadoop environment in the enterprises and research. Let's say, for example, here we are practicing the say three tools and something kind of this. But when you will go to the real field atmosphere, there will be a enterprise, or there will be an organization which will take care of your all the admin kind of stuffs, your cluster creation, your data management tool, and all these things. Similarly, it was previously for big data Hadoop stuff like Hadoop, HDFS, these kind of things. It will be Cloudera and Hutterwork. If it will comes to the Spark and all these things, it will be a, you can say, the Databricks. So Databricks is a cloud technology which we'll gonna cover in this course. So we'll write our all the codes in the uh, Databricks environment, and we'll create the cluster as well as everything. So we'll cover these are the tools. Again, coming to the what are the other benefits you will get it from my end, or you can say coordination team is the whatever the documentation we are presenting at the time of course going on. So that will be share soft copy materials, hard copy materials. Even if I'll guide you the free of the books, few things from Apache environments, I'll share my you can say Google environment to you, so that you can say you can be go through that books like Apache, high books, high data engineering books. There are some PDF books are there that will really help you guys. So these are the things you will get, and at the end of the things, will dedicatedly spend one session. Maybe it will be one or two, means 90 minutes to 120 minutes, or 60 minutes to 120 minutes for each student, for their resume preparation, for their you can say a doubt clearing Q&A session for their a mock interview kind of thing. So it's a one session at the end of the curriculum. Will it's dedicatedly for you guys to cover up all the things. So here, let's say for example, you guys have already working on the environment. If let's say for example, I don't, some guys is working 10 years in the let's say Java environment and you want to switch. So if I'll say that put 10 years of experience into big data, that won't help, because 10 years of experience showing something that he will be a architect kind of things, or he will be like a team lead kind of thing. So we'll manage how we'll show based upon your resume, based upon your working experience. We'll split your experience, we'll put something into here, something into theirs, and to maybe 3 years, 4 years, and based upon your experience we'll set up your project, whatever so what I'll do preferably best, ask people is that whichever project you guys are working on, just pull that project to me. I'll frame you for like, because you have already knowledge over that project, what is the source, what is the target, how the data is flowing, and all these things. So we'll frame your project, current ongoing organization project, into our data engineering project, or you can say big data environment. So we'll just replace the source, the table name will remain same, the pipeline will replace with some data engineering concept. Okay, it is the ETL load, it is the that load, it will be the batch processing load. So I'll say bring your project, we will do that. And these are the courses I already been discussed, prerequisites, nothing. I think you guys have knowledge on this. If not, I'll cover all these things on the scratch. SQL, I'll cover whatever the SQL required, Python whatever required, writing the code and all these things. Scala we have mentioned, I'll give on high level. I think Unix you guys have already knowledge. If not, I'll give you the whatever the required command to write down the Unix moving file, copying file, all these things, and this concept. And coming to the big data environment, these are the things which we usually cover, like data storage, data processing, and Spark will be the, this will be the cover up. So in the Spark, we will cover both real-time data processing as well as batch processing. And don't be worried, this session will be a combination of most focused on SQL, because in the real field, people are usually currently working on SQL. So the Spark things I can say, yes, programming is needed. Programming is needed to understand the curriculum, but there won't be much focus regarding the programming. So I can ask you to be ready with the SQL. I'll cover these things. Okay. So I think you guys, after the call, or after the, you can say after the session, will share this material. Our coordination team will share this material. You can guys go through that and will get extracted whatever you want. Okay. So, guys,
I have
yeah,
I have one question. Actually,
yes,
in this course, we are covering data engineering part from start to end, right? So, in start to end, whatever terms comes, kind of in the data processing, like data ingestion and data processing
okay,
and data pipeline. These things will cover, right?
yes. So it's all from scratch. So we'll learn how to inject the data till the last layer. Let's say, for example, you are working as a ETL developer, you have knowledge. We are getting the data from the.
Yes.
So in which ETL tool you are working? May I know?
It's a in-house tool. It's a Rage tool actually.
Okay, okay. So let's say, for example, we'll
Like
take.
you can say that tool is like a SSIS or Informatica like that
Okay, okay. You
tool.
can take as Informatica. So I have pretty good experience in Informatica. So what usually in Informatica, what usually happen, we'll take the data from the source layer. It might be a Oracle, it might be a you can say kind of file system. So there in
Yeah.
Informatica we have lot of transformation, like
Yes.
expression, inner join. You have like lookup. You have like everything.
Yes.
Router. Because I already worked 3 years in Informatica. Okay, so you can
Okay.
understand from the source will all the transformation will used. After that we'll push the last thing into the target. So in Informatica there will be two part, one is source extraction and last one is the target extraction, correct? In between that we
Correct.
have all the transformation. In the target extraction
Yes.
also, similarly, the way we create from the in Informatica world, we create the target out of the transformation. Similarly, here we'll also cover these things. How we'll transform the things. So for that, we need to write Python code to get the data, maybe, and SQL also, because you even if in Informatica or in any ETL tool, we usually write SQL code to change the logic kind of thing, correct? Because you can pass your update logic or insert logic in the any of the transformation. Similarly, we will do the same thing here. All will be remain same.
So basically, you are going to use Python instead of Scala, right?
Yes, because yeah. So coming to
Why am I,
why we're using yeah, tell me, Jubair, go ahead.
so why we are not going with the Scala?
Yeah. So if you'll say in the current scenario, okay, let's just give me a second. Just give me a second. You can see my notepad.
Yes, yes.
Yeah. If you'll say whenever we started, so it's, let's say for example, this is a Hadoop environment, or you can say this is a big data world. You can say, yeah, this is a big data world. So priorly we have four language for the data processing or coordination with Spark, you can say. So first one is Scala, then Python, then Java, then R. So if we will go currently, so let's say for example, you heard about two terms. One is MapReduce and another will cover what is MapReduce and what is Spark. So previously all this, you can say, native code was written on Java. So all the language when big data world started, so it was all Java, all Java, all Java. So that time, let's say for example, we'll write what is the scenario when it was started. And so when it was started, it was all kind of 90%, you can say. Similarly, when our Python started, when our Scala started, it was 70% of market, and some market was reducted from the you can say Java. Some 20% 70% market goes down from Java to Scala. So now remaining 20% is there in early, you can say, 2015. That time Python is only 5% in the market, and R is always a minimal. R never, no one, basically it's you can say it's 5% of R is always in the market. But what happened currently, this 2% of R always become a 5% become 2%. If you'll say the stack of 20, 22, this 90% is reduced to, again I can say, 2% or 5%. This Python is already boomed to 90%, and the Scala is, you can say, another 10%. I'm not going actually 100%. This is what current market scenario. If you will see this column was early 2000, we can say early 2015 or 7. If you see current scenario, this is the current scenario. So in Java, it's now already 90% of market share. So let's say for example data, so data engineering, data scientists, data analytics, everything, because of the high, you can say, high libraries, high scalabilities, good language, means easy to write, all this functionality are there. So that now the market value of Scala is dying. It's almost died, you can say. It's almost died, because what is there? So after the data engineering, it's the data engineering won't remains as a data engineer. Previously, what organization used to say, so data engineer stopped, means, let's say for example, what was happened and what is now currently going to be happening. I'll give you a overview. Previously, when year of
So you are
2010,
saying that, sorry to interrupt you. So you are
yes,
saying that Scala is no nowadays no companies are using much in the sense most of
yeah,
the companies
current,
using
Python,
Python, right?
yes.
Yeah.
And another thing is that data previously when we started in 2015, or you can say 2012, there was no concept of data science. Now you can see there is a concept called as data scientist. Previously what was happening, so there is big data. Let's say for example big data, people are using some ETL, using Spark. Then we are using some data engineering concept or analytics kind of thing. But now there is a new steps added as data scientist, or you can say ML, machine learning. This end part, na, this end part is always this end part is full of your, what I can say, all Python. This end part is full of Python. So what I'll say, as this end part is full of Python, so down the line this part also pushed for the Python language. Previously if till we are ETL or data engineering part, Scala was good. But as data science and machine learning is going for all Python, you cannot say no one is writing the data science in Scala. Have you heard this stuff, someone using Scala as data scientist? No. So let's say for example you are going to prepare chicken curry, so you will take raw chicken. Yes, you can go for vegetables and all these things, onions and garlic, but the primary focus should be chicken. So as our target is data scientist, company's target is data scientist, for that the raw material is needed Python. That's what we are going for, Python. And in the, if you'll go and Google it, or you can ask your real-time friends who is working in the data engineering part, so Scala is almost dying. So it's the value of 70% now reduced to 10 to 15%, and the boom of Python is going to 5 to 90%. Any doubt till now?
So is it possible, using Python we can extract data with any kind of file system, like
Yes.
delimited, comma separated? Actually, I googled a little bit to extract the file, so I got only that JSON file or CSV file kind of things only on the internet. So I did not find delimited files like space tab, or if you have a position file, then to extract the data from some position kind of things. So that we also do in Python, right?
So here I just want to make sure that, okay, let me open my notepad. Yeah. Okay. Let me open my notepad. So what is happening, so the files, you can say you are saying that delimited file and all these things, but basically the
Yes.
file in real world is comprises of two things. One is structured. I'm just going for a
Yes.
abbreviation: structure, semi-structured, semi-str, and another is unstructured. So whatever the things you are calling as, let's say for example CSV, ESV, tab separated, uh, text, all these things are coming under a structured file system. If you'll go for JSON, Parquet, let's say for example ORC, and all these lot of files are there. Abro, Vabro, there are a lot of things. These are comes under, you can say, semi-structured file. And unstructured like video, let me compress the video and give it to you and ask you to store. Let's say voice recording, all these things are. So what, yes, through Python you can achieve these things easily, very easily you can achieve these
Hmm.
things and extract and all these things. But whenever you are coming to the semi-structured and unstructured, then Python is a drawback. So what we are using, we are leveraging here, we are leveraging the functionality of Spark to extract the data for the Python and all these things. Yes, Python will be there, Means you can say the native language will be the Python, the functionality of Spark, and the framework of big data to scratch all these things. Yes, you can do all the
Hmm.
file. Let's say
Okay.
if you, yeah.
So we are combining Spark plus Python for the semi-structured data, correct?
Yes, even if for structure also will do, because
Okay.
the processing engine, if you'll write your code in the Python environment, the processing engine is the Python itself. The You can say the Python environment or Python engine. But if you'll write your code in the Spark environment, the processing with the language of Python, your processing engine will be the Spark. And why Spark is more advantageous, or you can say is the best tool as the ETL processing, we will cover in the maybe after 5 minutes, 10 minutes. Why Spark? Why not Hadoop? Why Hadoop is dying? Why Spark is in the market? And all these things will cover.
Okay. So currently we are not using Hadoop uh, in the sense for data engineering.
Yeah, we are using the concept of Hadoop is required, because what is there, the from the concept of Hadoop the Spark evolved. But the again I say that if we'll go on the statistics part, what I said in the here, so how this is dying, Scala is dying,
Okay.
dying,
Okay.
and Python is increasing. Similarly, the Hadoop concept is there, but the market value
Okay.
again is dying.
Python.
Hello.
Okay. Okay. So you are saying that Python has more advantage than uh, this Hadoop, right?
No, no, no. You didn't get the concept. You get it. So these are processing language. These are programming language. Okay. Big data
Hmm.
Spark, you can say these are programming language. Hadoop. Okay, let me go to Notepad and it will be here. So I think you just got confused. There are two things in the data engineering part. If you'll say the data engineering part, there is one is processing engine, processing, or you can say framework. Framework is to Hadoop. Another is, you can say, I can write Spark. Okay. Similarly, but you can say what, language. Language I can write. Language, there are four languages. Java, Scala, and Python. So you got that relationship. You can choose any of the language here. You can choose any of the framework, and you can choose any of the language. It's one to one,
Okay.
means all to all mapping. So
Yeah. Yeah. I
you
now
can,
I got it.
yeah, you can, these are framework. This Spark framework also you can using all these four language. This Hadoop environment also you can access by using all these four language. Got it? So what we are choosing here, we'll choose both Hadoop and Spark in the processing framework, and we'll choose Python. Specifically, when the big data world started, it was first Hadoop with Java. Okay, then the concept changed to Hadoop with Scala. Then concept changed to Spark plus Scala. Then current in the current scenario, 90% market is Spark plus Python. So let's say, for example, I'll let you know Sparks plus Scala, but it won't helpful you to search any job. If you got 90% of all in the market, all will. Do you have knowledge on PySpark? So the term now you will heard in everyone mouth is PySpark. It's Python.
Yes,
It's
got it.
Python plus Spark. So this term, everyone will now ask, do how many years of experience in PySpark? They will ask. So this is the things, you'll go anywhere. Yes, but in our concept we'll cover Hadoop as well, because the functionality of Hadoop, the way they design the framework of Hadoop, that was liberated by Spark. Means you can say this is big data 0.1. What is Hadoop is big data 0.1. Spark is big data 0.2. because let's say for example, what is the difference between Hadoop and Spark? Let me come to you. It's not, even if Hadoop, we can say Hadoop is a means all the technology is combined and it will come to Hadoop, but it's called as MapReduce, the processing engine, the MR or MapReduce. So what is happen, let's say for example, I will ask to you write a code, or let's say for example there are two systems are there, two laptops are there. One is 500 GB of hard disk, 16 GB of RAM. Another is, let me come to here, 500 GB of ROM or HDD, I'll write hard disk plus 8 GB of RAM or memory, we can say. So just make sure that, okay, let me give you one theory, one smart description. Whenever I am writing, I can write in earlier we said ROM, RAM, all these things, but these are terms are disk, memory. These terms are the data engineering terms. You have to buy heart these terms, because whenever someone is asking what is your system configuration or what is your cluster, you'll say, sir, I have a cluster of four cluster of 500 GB ROM and 8 GB of RAM. So they will easily know, okay, these guys never worked in real IT industry. This worked in somewhere else or some other technology. He has just same thing. But if you will say that, okay, sir, my cluster is composed of 500 GB of disk and 8 GB of memory. So that will be the data engineering. So here RAM is just like a memory, and you can say our ROM hard disk is just kind of a disk, you can say. And another system, I'll say nothing. I'll say only 256. Okay, 256 GB of memory. So any idea which one will process the fast data? The first one or the second one? If I write a code and ask you to Subha and Jubir, you can actively participate. This is the this should be an interactive session, so that you guys will be feel comfortable with me. I'll encourage you guys to be more participate in our conversation. It's a
I
kind
guess
of,
second one.
yeah. Subha, anything from your end? Okay. Is that anything from your end? I write the two things. Yeah.
It's a 256 only GB, right?
Yeah. Let's say for example, I'll write, okay, if you're getting, yeah, 50 GB plus 2 GB. This is 50 GB of HDD, and this is,
Okay.
you can say 2,
Second,
2 GB.
second one.
The second
I
one.
prefer second.
Similar,
Yes.
this structure is similar to difference between Hadoop or MapReduce versus Spark. Spark is always a in-memory processing. So here, the all the RAM size is more. The RAM size is more here as compared to Hadoop. In Hadoop, the disk size is
Hmm.
less and the memory size was low, but Hadoop has its own you can say own advantage. It's very low cost. If I'll say I'll purchase this laptop, this will cost me 50,000. If I'll purchase this configuration laptop, it will give me around 2 lakhs or 3 lakhs. So there is always an advantage and disadvantage of the things, but as per real field work, our processing engine should be much faster. So we go with this configuration, and this kind of configuration is achieved by Spark. So now we are achieving the Spark in memory Spark processing. So I think you guys now understanding why I'm going with Python plus Spark. Yeah. Okay.
Yes.
Then
Um,
I think, yeah, we are. Any doubt till now? I think you got overview and idea about what Spark and what is real field and what we are going to use and all these things.
Yes, yes.
Yeah. Okay. So let me come to the, I think this part also syllabus part, I think not much need to discuss many things, it's a waste of time I can say. You can go and check and all these things. So all the things whatever you are seeing in the market will cover here, and the concept of data warehousing, the concept of ETL and all these things will cover here. So will cover to, we'll go to the high view of big data, what is big data, and introduction to big data. It's a kind of demo why big data come into picture, because previously all ETL tools are there. Previously all the kind of stuffs are there. PL SQL is there, Oracle is there. Then why it's come to big data? Why big data is going? So what is coming to that? Whenever you will say that your Oracle environment will process a file up to 10 GB, 12 GB, 30 GB, 50 GB, correct? If it's coming to the petabyte, let's say for example there was no concept of online ordering, there is no concept of real-time data processing or this concept. So have you ever seen that Zomato in backend they are using the Oracle database? No, because they want the data to be in real time. Let's say for example our ATM, Zomato, taken Zomato of Swiggy or Zomato, you ordered something on at the same time the order was received by the Zomato app. The same time, within a fraction of second, not fraction of second, that is the nanosecond, because Kafka or Spark engine are saying that we are a data latency of nano up to 10 to the power minus 6. So the same second, the Paradise will receive your order or the hotel will receive your order. They will accompany, they will acknowledge your order. Okay, your order approved. At the same moment, you just order. Let's say, for example, you order at 10:46. At 10:47, you will get a pop-up called as your order has been approved by the so and so restaurant. After 5 minutes, you after 2 minutes your wallet will be assigned, okay, this boy Raghuram or something will be taking your order and reaching you. So and if you go and check the map, the where is driver, where is the order boy, and you can say all these things. So due to this real time analytics kind of things and all these things, so Hadoop comes into market. And again if we'll come to the how the data increases in over the years. So when we started in early 2000, the data limit was up to, you can see GB, we see that okay 10 GB file, 15 GB file. So up to that limit RDMMS or relational database management system was okay. But when the data level increases to 50 GB, 100 GB, 1000 GB, petabyte, gigab and terabyte of things, then the Oracle, the system, the legacy system like SQL Server, Oracle, and all these things, or even if ETL also, they died. If we will process a 15 to 20 GB of file in the all the our ETL like Ab Initio, Informatica, SSIS, they are going to die. The performance is very degraded. So the terms of big data, what is so big data will comes into picture. There are four very, you can say how this data is increasing day by day. So you can say that the whatever the data generated in the, let's say for example in world now is 100% of data. So around 50 to 60% of data is generated in the last couple of years. So earlier, let's say for example whatever the data is, you can see this graph how the stiffness of data going on. This data is going on like this. So so all these things, so new data and all these things coming into. So the five concept of big data coming to picture is why we are going for big data and all these things. So you heard that there are five concept: velocity, veracity, volume and velocity. So what is happening? Volume. So the volume of data increases, correct? So from the scratch, you will see the volume of data increases like anything from the after 2018. Then is variety of data. What is variety of data? So earlier what we used to do, we have like just we discuss, we have only this file, uh, structured file, semi CSV file or TSV file kind of thing. But after that, nowadays you can say lot of file, XML file, someone is processing JSON file, someone is processing Parquet file. So these are the variety of data. Previously, organization means only structured data, only tabular structure, relational database management system. Now we'll see structure, semi-structure, on-structure. Even if you let's consider example of YouTube. In YouTube, what they are sending, you are uploading your photo, you are uploading your video, but at the backend that is also getting stored. Correct, and that is also we are processing. You are writing something like movie by Shahrukh Khan, but it is getting searched and getting you the movie details, all these things. So how these unstructured data are getting stored? These comes into a variety of data from the different sources. Now you are getting sources from IoT devices, now you are getting sources from robotics, now we are getting sources from normal structured file, now we are getting. So all this comprises into a variety of data. And velocity, at what speed we are receiving. Previously one day one file is enough. Let's say for example, in legacy or culture, let's say for example banking system or something, they in a whole day what are the transaction they will do, they will write it in a CSV file or in a Excel sheet. So at the end of the day they will send it that Excel. But let's say for example in current scenario you will see that the Amazon kind of website. So every time people are doing, so every second, every millisecond you are getting the data. That is the velocity of the data, in what speed we are receiving the data. So, and coming to the data integrity or veracity, what veracity looks like, different data source at different speed, and we are creating all these things in a single point. So that is the integrity, that integrity relationship between the data. Let's say for example, I uploaded Anvesh, my name is Anvesh, in a structured manner, and I uploaded my photo. That what will happen? Anvesh is a structured, or you can say structured data, but my photo is a unstructured data. But both will stay in the same place, or both whenever you will retrieve all these things in the same way. So here is a combination between different variety of data. So data integrity concept, that is known as veracity. That's what big data comes into picture. And we already discussed this tells about why big data volume, veracity, and velocity. And you can find how this volume get into picture and all these things. And yes, these are the things why big data comes into picture, and how will performance, key performance, and all these things will come. These things will go in depth well in our upcoming session. And yeah, I can say then we already have discussed why we have gone with Spark. If yes, if it was big data or Hadoop is working fine, then why we go to the Spark environment to manage all this big data. And working with them in the Hadoop environment was is a time consuming process. So this same concept here comes into picture. If I'll write 500 GB with, if I'll ask to, with this system I'll ask to process 10 TB of data. I'll write a SQL, and I'll ask you to find something first name and last name from this concept, and I'll write 10 TB. Let's say for example, same thing I'll go for with Oracle and ask you to find. So if it will the let's say for example the Oracle at least will take 1 day to process 1 TB file, correct, or 10 TB file. The Hadoop environment, it will might take 50 minutes or something. But here in the Spark environment, as it's a in processing, all will be happen in RAM, it will take another 15 minutes or 5 minutes. So the performance of this Hadoop to, or you can say MapReduce or Hadoop environment to the Spark is around you can say one tenth processing speed of the things. So guys, these are the introduction to Hadoop, why we're using Spark, why we're using Python, why we're using big data, and all this concept. And you just got all the info regarding, yeah. Maybe at the end of the things we'll share all this concept, why Apache Spark and all these things. So guys, anything till now? We'll wait for 1 or 2 minutes to get heard from you. Hello, Jubair, Irsat, and Subha, anything from you, or we'll wait for a couple of minutes. We'll wait for 5 minutes of break, and I think again we'll get started at 11, sharp 11.
So yeah, so basically, we are totally new into it. That yeah, we know how the things working in the IT industries.
Mm-hmm.
So what we are expecting, we are expecting all the details from the scratch only, and the all the required material from your end, and all the infrastructure means in case of we need to practice or we need to some do the some POCs, we need the environment from your side as well. So you are going to provide that, right?
Yes, yes, yes. So the software you will get it from the coordination team. I think they will share you the Google Drive and you have to install that thing. Okay. And coming to the other environment, the Spark thing will run it in the cloud environment. Will I'll gonna help you to set up a kind of data bricks environment for you guys. So that will you will get a free edition, community edition, to write down your Spark code and all these things. I think in the second session I'll let you know how we'll going to write our code in Spark environment and all these things. And this is a cloud base, so you have to register from your Gmail ID and own mail ID. It is going to help. So there is no software for that one, so it's cloud. Yeah. Anything
Which
from
one
it?
we are using? Yeah, for cloud, which one we are using? AWS, Azure,
No, we are using
GCP.
Databricks. You are using
Okay,
Databricks.
Da- okay. Databricks is a cloud technology. Okay.
Yeah, it's dedicated for Spark only.
Oh, okay.
And if needed, I'll go through overview of Google Cloud Platform. But it's not in depth. I'll take 1 or 2 sessions, show you how Google Cloud works and all these things. But it's not in depth. It's a only kind of overview of GCP, Google Cloud. Okay, guys, I think we'll wait for a couple of minutes. Maybe we'll take 5 minutes of break up to 10, 11, 2 or 11:03. Then we'll get started after next hour of journey. Thank you. Take your break, 5 minutes of break.
Yeah, okay, thanks.
Hello guys, welcome back. Yamini, Rabina, and things. So I think we just had a discussion. So you can find few of that. We also discussed introduction, the demo. I think Yamini and for Rabina, we already had taken the demo and we have already discussed what are the things and Satya for you. So already we have discussed the demo with the new candidates. I think now we'll start up the few things from here. We'll take up the big data architecture. It's a new kind of journey. It's most important. You guys, I need your attention to go through the session and all these things. So will get started, or we'll wait couple of minutes for your break kind of things. Hello Shai, yeah, you joined today, so you attended the first class, Sai Venkatesh, or is this the second class for you?
No, today is the first class.
Okay, so you attended 10 to 11 demo, or you are in
No,
between that?
today only I started.
Okay, okay, okay. And what about Satya? You
Satya also today is the first class. He is my friend.
today is the first class. Oh, I think you guys joined 10 to 11 things demo.
Yes.
Okay, okay. Thank you guys. So okay.
No, 10 o'clock I didn't join anything else. I
So
joined
you
just now.
joined.
11.
Okay, okay. So then no problem. We have already a recorded session from 10 to 11. I think you can guys go through it. If needed, you can any doubt you can reach out to me in the next session. We'll cover whatever the things.
Sure.
So yeah. And for Rabina and Yamini, I think you already have been attended the things and you know end to end of why Spark, why Python, what is the introduction and all these things. Okay, without any wasting any time, let's jump into the today's agenda. Yeah, okay. Let me share my screen. We'll share the today's agenda. Yeah. Okay, guys. Okay. Without wasting any time, we'll start. So we already discussed what is Hadoop, what is Spark environment, and what is big data, and how these things are working in the real field. Why we come to this scenario. So any doubt till now, guys? So why Spark? Why Python? Why we are using all these things? Why Databricks? Yeah. For the session, will let you know why Databricks we using, because you can understand in the current scenario the boom for the cloud, because no one want to install the software in his local machine and try to all these things. All should be in a centralized location without any admin cost and all these thing cost. So we are more focused into writing our code in the cloud environment. For that we are going for the Databricks. So why Databricks come into picture? So the people who has developed Spark, the two guys who has developed Spark, they have given and developed the Spark, and they are given the foundation to the Apache foundation. After that, what they did the commercial way of Spark marketing, and they created a Databricks. So today we'll go through the architecture of Spark, architecture of Hadoop. Sorry, architecture of Hadoop. So in here Hadoop, so there are lots of component. So let's say for example, any problem statement you will take it off, there will be a lot of question. Similarly, when Hadoops come into picture, so it was processed with lot of things. Let's say for example, there should be a data, who should process the things, as people in the market was very familiar with the SQL kind of things. So where we will create that databases kind of thing. So what is the ETL tool we are using? We can say, let's say for example, I can write it DB, I can write ETL. So all these concept you can see here: data processing, database, ETL. Even you are saying, you heard one term as scheduling tools, orchestration tool. Any idea about orchestration tool? Scheduling, I can, again it will be resource manager. So all these things, all these components comes into picture, and they form a called term as Hadoop. So the Hadoop is nothing but a framework. So what is Hadoop? Hadoop is a framework. Hadoop is an open source distributed batch processing fault tolerant system. So the definition of Hadoop is a distributed plus open source plus batch processing, batch processing and fault tolerance. So all, so
Could you please
basically
zoom it?
this, yeah, yeah.
I
You
did.
want to zoom it?
Yeah, yeah,
Is that fine for you?
yeah. Good, good.
Yeah. Actually, a lot of things need to be covered. Okay, let me zoom in and zoom out. Okay, so this what happened. So when you will see these four features of Hadoop makes it very you can say demanded, or that makes the market lean towards Hadoop. So what is distributed? So whenever you are storing a data, let's say for example, you are storing your photo in your mobile. So that photo will be stored within your mobile. Once mobile is lost, the data will lost. But in Hadoop, what will happen? The data will be stored in different machine. Let's say for example, you stored a 50 GB of file. That 50 GB of file will stored in different chunks. Chunks means small kind of file, and it will store in different machines. So whenever you are processing, so there will you can achieve the parallel processing. So in parallel processing, what will happen? So n number of threads will be activated. That will make you the speed up the processing. So Hadoop, first of things, why we go for Hadoop? To achieve our performance. So if you're going for a sequential processing of our data, is that going to deliver you the performance? No. So we are going for a parallel processing. So for parallel processing, what we need? For parallel processing, we need distributed system. So in distributed means what will happen? Okay, let me go to my notepad. So in distributed system means there will be one, and there will be small thing. So I'll come to here. What is all these things, and why we are covering and all these things. Okay, so you can say these are all a distributed one. These are, let's say for example, I'll write it as I'll write an, okay, DN. Let me write DN1. I'll cover why I'm writing DN. So let me draw the diagram first. 3. Okay. So what will happen, let's say for example you passed something. Yeah. So what will happen, let's say for example I want to store 100 GB of data and I pass to Hadoop environment. So what do you think, is this Hadoop will store all 100 here? Is the Hadoop will store all the 100 GB of file here in the second DN2, or will Hadoop store all the 100 in the DN3? No, it won't store the whole data set into a single data node. Let's say what we are calling as data node. Data nodes means where the data will resides in our big data framework or in the Hadoop framework, that is known as data node. So whenever we are passing some data, it will split it into chunks and stored in different kind of machine. So in that feature will achieve our first goal, that is distributed, because the data is distributed between n number of data nodes. Why open source? What is open source? Open source means it's free of cost. Let's say for example in Informatica, you are going for Informatica, if you are going for Selenium, if you are going for kind of Java or IntelliJ. So these tools are organized by some of the vendor. So let's say for example for Informatica vendor is that they will charge some kind of amount to your organization, $500, 600. Let's say for example clear cut idea is AWS. Whenever you are using AWS in your environment, so Amazon is charging some amount of money to you. That is not some amount, that is huge money. If you go and see the real field, that is a huge money they are charging Amazon to your organization. But here Hadoop is a open source, it's a Apache organization, is open and free of cost. They will give free of cost to the software, you have to manage, you have to develop, and your, so that is open source. Due to open source, lot of people are getting free software, so all are lying towards the Hadoop. Okay, if free, who will not go? Then batch processing, I think I'll cover what is the difference between batch processing and real-time processing. But for this timing, just understand batch processing means same ETL job will store the data up to 30 minutes, and after 30 minutes what we'll do, we'll dump the data into the target system, we'll process the transformation or the logic will be applied on that concept, then we'll apply the logic and the output will be returned to the target. So on the fly real time, so let's say for example what we discuss like Zomato boy or ATM card kind of things, so that cannot be achieved in the Hadoop environment. Yes, that can be achieved, but that performance is very low, or that is a quite a challenging process. Correct. So batch processing means some data latency will be there, some time gap will be there. With after that time gap, will dump the file. Let's say for example in Informatica or any ETL process, you are pulling 30 minutes of record from the source, you are processing and dumping it to the target. After that process, again you are pulling the 30 minutes of data from the source, processing and dumping. But that is not real time, there will be a data latency between from the source to target. So whatever the data reflects in the source, that's at the same time is not pushing into the target. That is known as you can say batch processing. Then another term is, then if batch processing, that is the another way of processing the data, that is real time processing or streaming processing. In streaming processing like WhatsApp messaging, you are writing some messages that is delivered to your a friend. Is there any delay between friends? No, there is no delay. The moment you send, the moment she or he arrived, received the message. So that is known as real time data latency. So real time data processing, in real time world, real time or near real time data processing, there won't be any data gap between source to target. Just remember this term, what is batch processing, what is real time or streaming processing. Another is fault tolerance. What is fault tolerance? Due to something, let's say for example I have um, file situation. Okay, let me go to here. Let's say for example I have three computer working parallelly. Forget about this data node, these are the computer and this is our server. So let's say for example due to something data node 2 will be down or it's gone. So do you think these two will be got? No, these are independent, they will give their outputs to their master. So our work will be stopped? No. Let's say for example in our case, What is fault tolerance mechanism? If one day I will get feel sick, our class is over. So okay, Anvesh is not ready, so our class is postponed. That is single point of failure because I am the single person who is taking the class. Let's say, for example, take your concept. Let's you are attending 10 people. Someone who is not feeling well. Do our class will stop? No, because we are independent. You guys are independent of each other. You are not dependent. The way you are dependent on me, the same way you are not dependent to yours. So when our like say, let's say for example, you have some data. I have given 10 GB to you. Irsad, I have given 10 GB to Prabina. I have given 10 GB to Rabina. I have given 10 GB to Sai someone. So someone is absent. Okay, not an worry. 90 GB I can process. I can give the output. So that is known as distributed fault tolerance mechanism. So any doubt till now? Why? What is the agenda behind Hadoop? What is distributed open source batch processing and fault tolerance? This is the core concept behind Hadoop. Guys, I'll wait for, okay, let me clarify you guys. So I usually wait for 1 minute to get your response. If not, I'll jump into the next chapter. So let I usually do 20 minutes of discussion, then I will wait for 1 minute. Let's say for example we discuss from 11 to 11:20. We'll wait for 11 1 minute, 11:20, then from 11:20 to 11:40 we'll again start, and I'll wait there. You can, in this second, you can jump in and ask your doubt. Okay guys, let me go to the thing. So this is known as the core concept behind the Hadoop. Okay, so now we'll say what are the tools comes into the
Can
market,
you
or
hear
what
me?
are, yeah, I can hear you.
Yeah. So sorry. Can you just come again? The last part you just said, right?
Mm, what is okay, your fault tolerance mechanism.
Yeah, yeah, yeah. Fault tolerance. Yes.
Okay. Fault tolerance mechanism, let's say for example, in Indian team, there are there are 15 teams member, or they have 15 players they have selected. Let's say for example, today Rohit Sharma is not ill, not feeling good, he is ill. Do our match will stop? No, because we have other players to substitute him. Correct. Once Rohit Sharma will be ill, we'll pull Dinesh Karthik. So in this mechanism, so Hadoop environment, what will happen? Let's say for example, I have data in three the data nodes. Due to something, this data node is not working. Data node 3 is not working. So do our processing will stop? No, because I'll process with these two machine. Let's say for example, these three machine are working parallelly. Each machine one or data node one is dependent on data node two? No. So we are working independently. It's a parallel processing, so we'll not depend on each other. So there will be a fault tolerance, but I will cover up in the next what is how we can achieve the fault tolerance, what is the things. Okay, then you have a doubt, you can mind say that, okay sir, if data node 1 to 3 are working independently but they are working with master, correct? If the master will die, what will happen? So to achieve that concept in Hadoop, we have one more backup master is also there. So there is a, you can say, backup master is also be there, master 2. So what will happen if master, the moment master 1 will be die, so these all three will report it to master 2 simultaneously. So whenever who is even die, there is no impact to the Hadoop processing system. Any doubt till now guys? So let's say for example, once master 1 will die, so what will happen? These will report to these guys. They will go and report these guys. So whatever the things master 1 is handling, so master 2 handle. Let's say for example, in our case, there is one more instructor along with me. So if I will not feel well, someone will take care of this class. So this is known as fault tolerance mechanism. So there is no one independent, so everyone is dependent on independent of everyone. So there is no dependency while data processing, correct? Or you want any more clarification? Jubair, are you good to go? Okay, I think yes. Okay, so here what is data? So there are a lot of tools comprises to.
Yeah, we can go ahead. Actually, GoToMeeting is working slowly. So when I try to unmute, it's taking a time to unmute.
Okay, I feel we can say. Okay, so these are the tools we are making use. So whenever you will say that Hadoop environment, what looks like, okay, Hadoop is a single term. No, there are lots of component. This is Hadoop is a framework, and there are lots of component established within that Hadoop, which makes our processing or all these things are so here we after previous discussion we got to know two concept. One is data concept, okay, for processing. So will data get it from the source? So once we'll get the data, where it will get stored? It will get stored in HDFS. Just write down the term HDFS. HDFS stands for Hadoop Distributed File System. So at the back end, our data is always resides in the form of a file system. So HDFS is Hadoop Distributed File System. From the term D stands for distributed. So we saw here, we saw how the things are distributed one on another. So it's a distributed, and at the back end always our data stores in the file system. Again we'll come to the processing engine. Now I am saying that okay, we'll process the data, but how will process? There is a separate engine running on. Let's say for example you are writing a SQL query and submitted into the Oracle environment or MySQL environment. At the back end it is processing something, that is the SQL processor or Oracle processor. Here is the map reduce processor. There is a engine known as map reduce, and some other processing tools are there. Get later on it's come as a Tez engine and other things. Even if now in the market Spark replace over the map reduce. So I'll comparing both Spark as well as Hive, Spark as well as the HDFS. So map reduce and Spark both are the engine we will cover. Then what is database? DB stands for database. Simply write SQL. Okay, we first thing challenges how to store the data, we achieved through HDFS. Then second thing, how we process the data, yes, we achieved through MapReduce or Spark. But the many people has challenges there. In web 2017 they say that okay, writing Java code and submitting and fetching the data, writing Python code and getting the data is a very complicated way, and there won't be any developers. So every people, okay, you want to work on Java? No, I will not work. People are comfortable in the Hive. Even if you can see real field in our class, all are comfortable in SQL. Correct. If I'll ask to write down the code, are you guys to be helpful? No. You will simply say no, sir. Who will write SQL? So Hive is the SQL like language or Hive query language. It's a simple database. The way we are writing select star from table name, similarly we will write the way select star from table name, and you will get your data. Yes, the data gets stored, the data gets processed, the data gets stored, the data get processed by MapReduce or Spark. Then you, for the output, you are writing the SQL and getting the data. Okay, how this data from the thing. So internally all this driven through by the Spark engine or Pig engine, but currently no one is using Pig because Pig, I whatever the slash before like MR Pig, these all are outdated in the market. No one using in the market. That was replaced by all Spark. So the single term Spark replaced MapReduce, replaced Pig, and somewhat extended up to Hive also. But yes, but in interview someone is asking Hive things, and okay, so I develop all this pipeline, I develop all this logic. Then how will schedule the tool? It's not automatical that I will write select star from all these things, because night 12 I need to run my job. So would it be anyone will be available to write down the code? No. For that we want some scheduling thing where we schedule our job, it will run and it will get the data and it will deliver. So for that, previously there was Uji, now we are using Airflow. And even if Spark is has own its scheduling tool as well as, so what I will write as well as Spark here. So Spark is also its own scheduling thing. So that will make the sense. Another is resource manager. So resource manager is thing. So whenever I'll store the data, who will take care of the or the resourcing kind of things, where my data will store, where my data will how much data will be stored. Let's say for example here I passed, okay, 10 GB of data will be stored here. Let's say for example I pass 100 GB of data. So I pass 100 GB of data to store. How many will happen? Let's say for example it will store 50. Again it will say 40. Again it will store 10. So who will take care of this decision? 40, 50, 10, and maybe 40, 40, 10. Who will check how many? Because how this data allocation will be there depending upon the number of free size. When there is free in the, okay, this data node is very free, very less data is there. So we usually store more data. Okay, this data node is having more data, so we won't store much data here. Correct. So this decision will be taken care by a one resource manager. So this is known as resource manager, or you can say here we are going to yarn. Yarn is not yet another resource negotiator. So what is the full form of, so did you guys get the full form of everything? What is HDFS? Okay, I'll pass you the things, but for the timing, let me write HDFS is Hadoop distributed file system. Emerge term for map reduce. Reducing. Just remember this term because this is the most critical. The Hive is nothing. Spark yarn. So yarn stands for yet another resource negotiate. Okay, just ignore the spelling. But the yarn starts for yet another resource negotiator. So this concept stands for this thing. So any doubt till now what is and how this work is going on? What are the tools and what is the technology you are using and what is Hadoop and all these things? Okay.
Yeah, basically, yeah. So as you said that HDFS, uh, so it's using the MR map reduce, right?
Yes.
And what? So basically, Hadoop and Spark, these are the two frameworks, right?
Yes. Hadoop and I
So
didn't hear you. Voice is slow little.
so basically, the Hadoop and the Spark, these are the two frameworks,
Uh-huh.
and we
Yes.
are talking only about this only Hadoop right now.
No, we are using, yeah, current scenario in the current class we are talking about only Hadoop architecture. In the
Okay.
upcoming session,
So
we'll discuss about
so
Spark architecture.
so how you are connecting the MR is we can use the map reduce as well as the Spark, means map reduce and Spark.
Mhm.
So map reduce is basically for the Hadoop only, right?
Yes.
So how we are comparing that we can use also Spark with the instead of the map
Okay.
reduce.
Okay. Let me come to that point. So what will happen in the thing? Okay, let's say for example this is a data node. Okay, in a single data node we have three component. First, let's say for example take your example of your computer. There is one hard disk. Like every machine has three component. One is HDFS or plus MR plus you can say local LFS. Okay. So there is a you can say there is a segregated layer. You can say there is a segregated layer for HDFS. There is a segregated layer for MapReduce, and there is a segregated for layer of local file system. Okay, let me draw one more thing. Okay, let me draw here how actually the data resides within that. So you can just for the timing you can concentrate on the left side diagram. What I written, it's a computer. Think about it's a computer. We have some computer. There are in a computer there are three components like a data node. This is computer means a specific data node. Here in each data node there are three concepts. So the first concept is data. I say data node. So in a concept, so what we say that this is the scenario what data and processing as totally different organization. So let's say for example in your laptop you have a hard disk. Due to something, can I take your hard disk and fit it into the other system, Jubair? Yes, I can. I can take your data. I can take your hard disk from your laptop and feed it to the other system. Similarly, whenever some incoming data will come to the any data node, so it will resides in the HDFS box. It will resides in the Hadoop distributed file system. But is it compulsory that we will process with the MapReduce? No. I can take something here out there and I can process here using Spark. Correct. So similarly, just think about your laptop is having a hard disk. I can with means I can open your laptop. I can take the hard disk and process it and I can attach that the hard disk to other things. Let's say for example your pen drive. Most is the pen drive is particular to any laptop? No, I can attach the pen drive in n number of laptops. Similarly, whenever we'll push the data, these are data nodes. Means you can it's a kind of a you can say it's a computer. Whenever you store a data, the data resides in the Hadoop. So Hadoop. Similarly, we have some local machine also where all the libraries, Spark framework. In the LFS, what will happen? We store all the Java application, Hadoop framework, Hadoop coding, all this, the Hadoop script, and all these things. So our HDFS data will show, or the Hadoop distributed data will store in HDFS. That will process through MapReduce in the Hadoop framework. But whenever we'll switching to Spark environment, will take this data and will process in the Spark framework. So we these both are processing tool. It's independent.
Okay.
What, Jubair? Yeah.
Okay.
Just think about your pen drive. You pull your pen drive is a data layer, or you can say HDFS. You attach to one laptop, attach to a one laptop. You process. Similarly, you take your pen drive and push it into the other laptop. You can process. So you can another tool is there also, Tej engine. So that is also not very famous, but similarly also Tej engine also you can process. So if in the underlying database or in the file system you can apply the logic. So this looks like, so this I written a dn1 dn2 dn3. Internally this looks like this layer, some local file system. LFS means local file system. I'll write. Okay, let me write here. LFS stand for local file system. Yeah. So what will happen now? So every computer has its twin component. One dedicated for Hadoop distributed file system. One is LFS. What LFS is that? LFS is the common utility area. In common utility, let's say for example, I center. Your Oracle is installed in a server. So for installation of Oracle, similarly the installation of Hadoop is done in the LFS environment. Here all the Hadoop software will resides there. Your MapReduce framework will be there. If you install something, let's say for example, someone installs Spark tomorrow, Spark will be stored there in the LFS, and it's a processing engine on top of this data node. If you want, you can replace with the that processing engine will be there. You can, if you want, externally you can pull your data to the Spark environment and process there. Guys, any doubt? Okay, if no, let me push to the next topic. What is the architecture? So in this page, we'll get understand what is Hadoop, what is the component of Hadoop, and what are the these tools are associated with. What is the concept like? What is data? What is processing? What is all these things? Yeah, there is a concept of data locality. I'll cover what is data locality. So, but for the time being, we'll more focus into the architecture. So in architectural point of view, guys, please don't do these things, pass your mobile number and all these things stops. That really is not professional way of attending and doing all these things. I won't really encourage you to do this kind of things here in the classroom. Please guys, I don't encourage you to sb. Who is the sb, I'm not sure, but I will never encourage this thing. So only coordination team has all this accessibility and all this work. I think they guys might have take care of the things, but please don't, if you feel bad or I might be little harsh, but don't do these things. We all are professional, and we all are here to be professional way. It's your all decision, and you can take your independent decision. What I think, it might be harsh, but it's the untruth, uncommon truth of the things. Don't pass your mobile numbers. Don't pass other things in the chat. We are here in a professional way, and we'll conclude. Thank you guys. Hope you guys understood my concern. Okay, we will jump into the next topic. We'll ignore all these things. Okay, so what is the architecture of Hadoop and all these things? Okay, hopefully we are there. So Hadoop architecture is commonly based on two terminology: master plus slave architecture. Okay, so you all aware of that early years, how this master slave organization. Don't think about a early stage. There is a king, and we all have soldiers. So king used to do anything. King will sit idly, and they will order that soldier. Oh, okay, do this one, do that one, do this thing, that do that thing. But king has all the knowledge of doing things. So similarly, this Hadoop also do the same thing, master slave architecture. Let's say, for example, in our organization, is your manager doing to do the sprint work? No, manager never will do your sprint work. Whoever working in other things, is your manager solve your incident or mail work? No, manager simply sit idle. He schedule meeting. He will like, okay, do Anvesh, do this work, Anvesh, do that work, Anvesh, do this work. So manager is only for managing the things. So similarly, the Hadoop concept was built on this technology, looking at IT technology. IT is so what will happen here? I written master one. So master will simply sit idle. It will only receive the request from our end. Let's say for example, some user want, I want to see orders data, so they will fire a query like select star from orders. That request will go to master. Master is only get the request, that's it. Then he distributed the work among the data node 1, data node 1, data node 2, data node 3. So these are commonly told as workers. Workers. So similarly, worker 1, worker 2, and worker 3. And worker 3. Okay. So data. So from here, okay, let me write what is that name here. This is name node. Okay. So you guys, so in the master server architecture, what will have, this master is only meant for giving you the updates. Do this, do that, do that to all the data node one, data node two, the data node two. So the master is knownly or commonly known as, because if you organization, you will say that okay, I submitted job to master one. So it's not look good. So they change the naming convention to name node one, and workers is configured to the data node. DN stands for data node. Data node. So this works basically means this architecture stands for master slave architecture. Here the master will be there residing. He will submit. He will ask the employee or the worker to do the respective work. So what will happen? One job will receive from the name node, one request will be received, you write down some query, you ask some programming language, write down. So it will ask to go and here check, do this thing, check here, do this thing here, check, go and do this. So in between one layer is there yarn layer, you can say yarn. So what yarn will there? I will cover in the next upcoming session why yarn will be there. So yarn will be responsible for which data is available where, which job to execute where, which means how we'll process these things. All these things will be taken care by the yarn mechanism, or you can say the yarn concept. So another term is here job tracker and task tracker, right? I'll write the word, so please just listen all this word, we'll discuss more details into that, because once you'll understand the so TS stands for task tracker. TS, okay. So because this architect, once you'll get through this architecture, na high level architecture, how these jobs is getting executed, how the things, so it will be very easy, because unless until you understand the architecture on high level, so you can't understand what is the things. And there is always a communication between the master to that slave or the work node to the data node. So each 10 second they will have a discussion between them. So this is known as, this concept is known as heartbeat concept. Like every day to day, before coming to home, you are updating your manager, okay, so boss, I have done this work today, I have opened this incident, I have replied to that mail, and I have done this sprint. So the update you are giving to your manager is similarly the task. The data node usually in 10 second, it you updates the a response to the name node saying that okay, I'm doing my work, I'm doing work. This is known as heartbeat or workers response, or you anyone say data node response, heartbeat, or data node you can say heartbeat. Similarly, also in each 10 second, worker used to check whether my the master or the name node used to check to the data node whether the worker is working or not. They sleep or they corporate, or so this is known as master's heartbeat or master's response. So there is always a two-way communication between your task track. There is a two-way communication between your master to workers. So this is known as heartbeat concept of architecture. So let's say for example someone got died. So okay, master will know, okay, this data node 1 is down. So I have to means achieve my job by using data node 2 and data node 3. So on a high level, did you guys understand what is the architecture of Hadoop? We'll go in depth how this job will go and how this job will the things, and how we'll get the various functionality called as fault tolerance. Okay, one more concept I just highlight to one there. Okay, yeah. Okay, so Hadoop is also famous for doing one work is high availability. So one more concept is the high availability of the data. What is high availability data? Similar concept, same more or less similar to the distributed mechanism. So when high availability, what will happen? Let's say for example, I passed 100 GB of data to get stored here. Okay, I passed, okay, store 100 GB of data. So what this 100 GB of data will happen? This data will not store in a single machine. We already configured some crunch will be stored in the data node 1, some crunch will be stored in data node 2, but some node will be, let's say for example, this is a data we ask to store. So what usually will do, Hadoop is so famous that it will create three copies. So the replication factor, I think you, okay. So what will, so it will create three copies of this 100 GB. So like duplicate. So it will create the same duplicate, two more duplicate. I have a original one duplicate, and I have created another two duplicated. So now how many duplicate data replication is happened? So the replication factor is 3. So these three copy will store here, here, here. In the next upcoming session, I will say how chunks and data will be stored in all ratios, so that whenever anything goes down also, let's say for example this is goes down also, this there is an algorithm to store all this data to the respective data node. So anyone if also die also, nothing will happen. So this is a replication. Let's say for example, uh, your parents give you a one apple, but anyhow you manage to give it three apple, a replicate of the same apple to two other piece. So now you have three apple. Let's say for example one apple got rotten also, or waste also, there is no impact on your food because another two apples is there to eat you. Similarly, the same data whichever we are pushing to the source, which you are pushing to the Hadoop, that will create three replication factor, that is known as replication factor. So that if at any moment one copy of data also lost, another two copy of data will be highly available for the processing. This concept is known as high availability concept. Any doubt on high availability concept? High availability is achieved through the replication factor. So many interview they used to ask what is high availability, what is the concept of high availability, fault tolerance. Just by head these terms and means understand, because many question, many interview will face this question, what is the features of Hadoop and how you will achieve this. So you will say that the Hadoop is a distributed means why our data is distributed to three data node. In this concept we will achieve distributed. What is open source? That this is free of cost tool, that is open source batch processing, because we are not achieving
Anyway,
streaming, we batch process small chunks data in process, that is batch processing. Fault tolerance, because everything is a if someone will die also, our processing system won't happen, our data processing will stop. That is known as fault tolerance. Fault tolerance, even if I show, there is a in upcoming session will cover, there is another name node will be there, that this is called as backup name node. So what will happen if the main name node 1 will be die, name node 2, this is known as backup. So what this backup name node will there if the name node 1 will be die.
Your voice is cracking, Anvesh.
My voice is not good. Hello.
No, it's cracking. Is it for me or anyone is facing the same issue?
Yes, I got. I also got some of the some cycle instrumentation is on.
Okay, okay. Just give me a second. Yeah. Is this fine now, guys?
Yeah, now it's fine.
Yeah. So what is happened? There is a backup of name node. Similarly, we have data node 1, data node 2, data node 3. Similarly, we have a concept of two name node. One is name node 1 or two master. You can say in your company also there is concept of manager and team lead. Say manager 1, manager 2. If manager 1 is absent today, is not coming office, so manager 2 will in that case take care of all incident, all sprint, or you can say all mail chain. Similarly, or your team lead. Similarly, we have a data node 1 which is correct always work as a active manager kind of thing, or active master. It will, let's say for example, due to some reason there might be a chances in which server this data node was installed. That might be, let's say for example, I installed this data node 1 in the Chennai server. Due to flood, the Chennai is gone. Similarly, so my processing will stop? No, because I have a name node 2 which is installed in San Francisco. So whenever Chennai, it's very rare that Chennai and San Francisco both server will impact at the same time, correct? So at any cost, my name node 1 will be got affected. My name node 2 will be there. So in this case, what will happen? This data node, sorry, sorry. So what will happen? These, okay, yeah. So let me
Any
take this.
network issue at your end, Anvesh? I can. There is
Uh-huh.
a voice. Your voice is cracking.
Now also it's going. I think. Is it for everyone or guys, or is it for? Can you please confirm?
No, your voice is clear, but Jubair voice, don't I think so. Signal is not there. I think so.
My
Looks like
voice is
issue at
clear.
my end.
Okay. Anyhow, last couple of minutes to cover up the things. There is not much more left. Okay. So we'll last only 4 minutes to go. So because what will happen? So at any cost this will die, this name node 1 will die. So what will happen? So at every point, similarly the name node 1 is you can say is in communication with the task track with this data node 1. There is a heartbeat response we just discussed. Similarly, there is a communication between name node 1 and name node 2. So what will happen? Whatever the information the name node 1 is having, it is used to communicate to name node 2. Name node 1 having whatever the knowledge, it will pass to name node 2. So whenever name node 1 will die, or it won't work, this name node 2 will work. So so this is known as backup name node, or you can say fault tolerance mechanism. So this concept we have maybe covered up. So what is fault tolerance? It at any point, because anyone will go die. Let's say for example, if you will come about data, because I have data stored in three system. This whole 100 GB of one copy will be stored in this data node 1. Second copy will store in data node 2. Third copy will store in data node 3. So independent. So if anyone will die also, no impact. Similarly, I have a backup data node as well. So anyone will die also, any name node will die also, no impact. So that concept is there. So by this way, so here what we are we are taking two things: backup of data node, backup of name node, backup of master, backup of slave. So always there is a backup availability in Hadoop. So anyone, irrespective of anything, will die, the other will pitch in and start working. And high availability, I already saw the same way that fault tolerance is more or less same to the high availability, because always there is the data available for the processing, irrespective what will happen. If network issue, no concern. If anything, there is always the data is available to process. That is known as high availability. Okay, let me come to the next point. Okay, I think this is okay. What usually I do, whatever the things I usually cover, I have a handwritten note from my end. So I think we covered these things. What is Hadoop, MapReduce, Yarn, Hive, Scoop, and we discuss the things. What is Hadoop and all these things definition. And this part we already discussed. What is MapReduce, what is HDFS. Okay, here is one more concept I already written: LFS. That is local file system, that is similarly known as utility. So in utility, common utility, what for this framework, whatever the things needed, like for this framework we need Java library, we need Java to be installed. Okay, for Hadoop, Java is compulsory because the MapReduce code was written in the Java. So whatever the software related to the framework, that will be stored in the LFS or utility box. Yeah, you can find. So every data node or every computer is commonly based upon these things, just think. So whether it's name node, whether it's data node, this is commonly comprises of these things. Always MapReduce will be there, HDFS will be there, Yarn will be there, and common utility will be there. The common utility is same as LFS, you can say. So I think we okay. So how this HDFS concept, file system concept, came into picture? This file system concept was actually taken by Google File System, GFS. So previously, I think you guys of know in our you so that okay, I have uploaded the data in the server 1, server 2, server 3, or you can say that have you ever worked in WinCP or Putty, these kind of things? WinCP, server to server communication between, or file mount also, these are the file system. So similarly, Google File System was one concept. Similarly, that data replication and data copy mechanism, that was taken from the HDFS concept, was built on the Google File System, and which is a distributed storage. Okay, there are another two terms will be comes into picture: what is distributed and what is parallel processing. There are more who means highly, I think distributed we already process, because the data is not stored in a single machine. It's residing in different machine or different data node. So one another term is that, like, parallel processing. What will happen in parallel processing? Let's say, for example, okay, let's come to this picture. Yeah, let's come to this picture. So let's say I submitted one task. I given your manager has a big project. So what will happen in a single project? You have three tasks. Maybe someone will be a data engineer or someone will be a SQL admin. So these guys will work there on SQL part or SQL part. Some are programming language or software developer. They will work on their software part, or they will write their Java code, Python. Some are UI developer, Tableau, someone will work on the UI part, Angular, JS, and all this. They will work on the Angular part, and someone are also BI part, Tableau developer, Quick View, Quick Sense. So all these teams are independent on each other. They are or working independent of each other. Are they dependent on each other? So is that okay? Once Anvesh will fill, someone else will take. No, these people are working because I am working on my SQL part, BI team or Tableau team is working on their part. So all are parallel processing. Similarly, let's say for example I submitted a task to the master one. So what will master do? Master will divide the task into three parts: task, subtask 1, subtask 2 and subtask 2, and they will submit this task to independent this thing. So these data node 1, data node 2 and data node 3 will work independent of the features. That is that. So you can see there are three threads are connected every time. There are three threads. So these means to the parallel processing. So data node 1 will never wait on that what data node 2 is doing. So dn1 will never wait, okay, dn2 is working or not, he will start his own work. dm2 is also doing his own work, dn3 also doing his own work. So these are, there is not a sequential processing. These are let's is a kind of parallel processing. What is sequential processing? Let's say for example, let me draw one, let me draw two, let me draw three. Guys, can you find a difference between these three things? So here the master is directly communicated to each data node independently. But here what is happening? The name node is giving only talking with data node 1, and once the data node 1 job will finish, it will pass to data node 2. Then once data node 2 job will finish, it will pass to data node 3. And once the data node 3 job will finish, it will go to the name node. So this is known as sequential processing. This is known as parallel processing. You can find the difference, guys. Here each are independently working, but here data node data node 2 will only start work when it will get output from data node 1. So this is not the concept of parallel processing. So this is the concept of our Oracle kind of thing. Now even if Oracle or SQL Server 9, every database change their architecture to parallel processing, there is no sequential processing exist here in the real world. Maximum of things are kind of parallel processing. But earlier, like you can say in 2015, this concept was there of SQL processing. But Hadoop, all the data node are independent of their name node and they are working independent to each other. So there is no concept of you can say sequential processing. I can. So there is no concept of sequence processing. So these all the architecture which you see is a concept of parallel processing from here to here. So guys, any doubt? I think our time is over for today. So any doubt till now? What is sequential processing? What is parallel processing? And how this is the overview of architecture? How data node, name node, and job. These things are, yes. There are few concepts like job tracker, task tracker. We'll discuss in the upcoming session. So I'll show how this job tracker, task tracker, resource manager, and yarn come into picture. What happen when we submit a job to the master, how the flow will flow, and all these things. But this is the overview diagram because of the architecture. You have to understand the architecture because same architecture will also go to the Spark also. There will be any change, little change on top of that. Once you get understand or used to the architecture overview of Hadoop, then it's very easy to going forward. Okay, guys, we will wait for 2 minutes or else we can conclude the class. Anyone is any doubt, please let us know.